So, okay, so again, the idea is from the polar area. That's, again, that was on your formula sheet. You need to know that one. R squared. I guess it's dr, right? That feels wrong. D theta. It's d theta. Okay, and then your limits of integration. All right, so for this one, we've got from 0 to pi over 2, and r is 3 minus 2 sine 2 theta. Oh, sorry, pi over 2, thank you. Squared d theta, and then plus the, again, what you had was fine, but it's just a quarter of the circle, and since the radius is 3, it's just pi r squared, so that's 9 pi over 4. What did we say it was? 9.708? Yeah. Sound right? Mm-hmm. Okay. So that's good. Questions on that? You want to look at the scoring guideline right now so you can score it? No, let's not. Let's do it at the end. Let's do it at the end. All right. Question 2, for the curve, find dx d theta. What must you do here? What do you have to do? Yeah, we got to have x. We got to have an x. What is x?
R cosine theta.
Oh, that was very nice harmony. R cosine theta. All right. So we have r, 3 minus 2 sine 2 theta. And then that just gets multiplied by cosine theta. And then it's just a matter of taking the derivative of that. I'm not writing it again. And you can't do this on the test. Don't do this. I'm doing it for our sake. Actually, I guess the x wouldn't be there, would it? Ooh, that was a giant. Yeah, I definitely would not write an arrow. You would write it all again. Ugh. All right. Speaking of writing it all again, all that would go in there. All right. Now I just don't even like that I'm doing that. So I won't. I will. There. That's better. But we're evaluating at theta equals pi over 6. Something else I noticed on some of your guys, make sure when you do this evaluating thing that you put the whatever you're evaluating at the bottom of this line. I saw somebody or a couple people had it like in the middle. I don't know. I don't know if it's a big deal, but I'm starting to believe that stuff like that matters. I don't know. Yeah.
Can you put dx d theta, parentheses, pi over 6, equals?
All right, so the question is, can you do this? That's the question. It's not conventional to do that because is x pi over 6? Is theta pi over 6? Which is it? See what I mean? Yeah, this is the way to do it. I get your question, but
What if I just put like what x equals and then just put dx d theta equals the derivative of what I'm doing?
so you took the derivative. Well, wait, because we don't actually find the derivative of this. Right? We find the derivative evaluated at that. At least, you didn't try to find the derivative of this whole thing, did you?
Yeah.
Like longhand?
Yeah.
Oh. What? Don't do that.
Oh.
This is a calculator.
I did it.
Yeah, no, this is a calculator problem.
Whoops.
Yeah, no. Do this in the calculator. Yeah, again, think about time. As soon as you get into the weeds on an FRQ, right, it's going to happen. At some point, you're going to be doing a problem, and you're like, man, I feel like I'm sitting way too long on this. Ask yourself, can I use a calculator for this? Because if you can, You probably should, because it'll take less time, okay? Anyway, what is the answer? I have it, it's just on a different sheet.
I got negative 2.366.
-2.366, correct. Okay,
0 for 2, guys.
ooh, nothing?
I
Yeah,
thought that one was just finding the derivative.
I'm gonna be honest, I looked at yours, because you turned it in first yesterday, I'm like, oh, you must have been working on this during history class. Or something, what class?
I got the last.
What class were you working it on?
Religion.
Religion, okay. I thought you're not allowed to use iPads in religion anymore.
I don't have Mr. G.
Oh, okay.
That is true.
Mr. Whalen too, huh? All right, anyway. Okay, this one some of you made way too hard. Way too hard. The distance between the two curves changes from 0 to pi over 2. So yeah, this distance, this distance, this distance, all these distances between the curves, right? Well, what is it really? When I'm looking at the distance between these two curves, what is the difference that I'm actually looking at?
The function.
Yeah, the difference in the radius, right? So like, if I look, for example, I'm looking at pi over 3. So pi over 3 is up here-ish, right? So if this is the radius of the circle, and this is the radius of the other thing, I'm just subtracting those radii, and that'll give me the distance, right? Well, so the radius of the circle is 3 at pi over 3. What we don't know is the distance, the radius of the weird thing. So how do we find that? Or do we know that? We do know the radius of that thing. Yeah, it's, what is it? 3 minus 2 sine 2, is it theta? No, it's just that?
I got that part in the job.
Isn't that the radius at pi over 3? This is the distance, but it wants to know, find the rate at which the distance between the two curves is changing, okay? So what I'm really doing here is I'm taking, actually, let me get rid of that. I'm getting rid of this pi over 3, changing. I'm gonna leave it as theta. What I'm really doing is finding the derivative with respect to theta of this at theta equals pi over 3.
Do you have to put like another parentheses around the 3 that's the thing?
Yeah, I probably should, yeah.
Well, I just want to make sure because I haven't had it described.
I don't think they would dock you if you had the actual thing right, but I don't know. What happened? Obviously, did I say something funny?
No.
Okay. Anyway, the answer is, yeah, I know, hold on. I think I forgot to record all this. I don't know. Sorry, Grant, if I did. All right, there's your scoring guidelines. Good?
Yeah.
All right, next parts. So now, expression for the distance. Notice they say expression. Here they simplified it. You don't have to. So long as you had this expression written down, you didn't even have to write d equals. So somewhere you have this, you're good. Okay.
What if it's like I messed up the answer, but I put 2 sine 2 times pi over 3.
2 times.
Because like I messed it
So
up.
did you ever show you find the distance,
I mean, like,
or you did the distance in your head and then you just plugged the
in a
pi over
weird
3 in?
way, it's like here, but it's kind of like scrambled.
Yeah, I think I'd give you a point for that, even though you plugged the pi over 3 in wrong. Yeah. Yeah.
Okay, so I wrote expression, but then in the front of it, I put d theta. Does that get it?
So, okay, so is there an expression for the distance in your problem?
I have d theta that.
Yeah, I think that counts. You have the expression for distance, even though you didn't necessarily explicitly state it. I don't think that's what this means. So if you wrote d over d theta of this, then to me, then yeah. Okay. All right, so here's what we were talking about. This part, I was right. You do need this. You do need this. You do need to write this out. So even if you just did it, you have to show why you did it. Okay. So if you didn't do that, again, this is what I was talking about, that chain rule piece. Okay. If you didn't do this, if you didn't have this written out, you're not getting that point. You get the answer right, fine. Okay. You didn't even have to do this. You could have actually just found it or written it down. I guess we did kind of write it out. Times 3. Okay. All right, I'm going to do the averages different today because, I don't want everybody to see what they got. Global mean. Okay, now we had 7 of us. Oh, wait a minute. I'm missing somebody's score. Hold, please. No wonder it's so low. I divided by 7 and I didn't have everyone's score. All right, never mind. I'm missing one score.
Okay.
You got it yet? Oh, you don't get it. The answer is you don't get it. No.
Okay, but so that wouldn't work.
No.
Okay.
You don't use the chain. You didn't use the chain rule.
I did though.
You didn't show it.
Oh my god. Okay.
Yeah.
That's
All right.
fine.
Let's see what that did to our
But I did it in
average.
my head.
Yes, you have to write it. Doesn't matter. Don't do it in your head. All right, that's better. Whew, that made me nervous.
Are we above the global mean?
We're above the global mean. Okay, now, so that's good, but obviously this is stuff that we covered that was new material for you, right? We didn't go over this before. So log this somewhere. Hopefully you made a sheet, a note like we talked about that day. Polars and parametrics better be on your sheet of stuff to study, right? And finding, and honestly, go on to AP Classroom. There's videos for that. There's extra practice for that. I know we haven't used AP Classroom very much, and I'm not going to assign you stuff because at this point, we should be at a place where you need to figure out what it is that you need to study, right? I don't want you if you did great on this, then don't spend a ton of extra time on it, but maybe you're bad at, the washer method or something, you know what I mean? So that's where